Okay, so we just kind of introduced classes. Next, I want to cover briefly some nomenclature that we use with classes and other object-oriented aspects of Python. So this is from Learn Python the Hard Way, exercise 41. So we'll go over this quickly, and then you'll have it here as a reference. So when we use the command class, we talk about class, we're telling Python to make a new type of thing. Object. Um, an object can really be the type, or it can be the instance, right? It can be a type of object, or it can be in the instance of an object. An instance is what you get when you tell Python to create a new class. Def is how you define a function inside a class. We've seen those before. Self is inside the functions of a class. Self is a variable for the instance or object being accessed. Inheritance and composition, we'll talk about those in a minute. This is the idea that you can inherit traits from another class. And composition is this idea that you can compose a class of other classes as parts. So you can grab parts from other classes and use them in your new class. Rather than with inheritance, you're inheriting everything. An attribute is a property classes have that are defined using composition, and importantly, they are usually variables. Whereas I'm going to add one here. As usual, I will update the IPython or update the notebook on GitHub. Method is a property classes have are usually functions. I think they're always functions. Then there's this concept of is a and has a, and basically this is a way you can think about what you're doing when you're creating a class. Is a it's a phrase that says that you're inheriting something from another. So a salmon is a fish. So a salmon has all of the properties of a fish, right? So an instance of a class has all of the properties of that type of class. Where has a is a phrase to say that something is composed of other things. So a salmon has a mouth. So a mouth is not a type of thing. A mouth is just a property, and an object can have certain properties without being. It isn't that property. It just has those properties. So for example, if when we write class xy, this is make a class named x that is a y. Most common example is we're making class x that is an object, and then we're defining an init function that takes itself and j. So this class x has an init that takes itself and the j parameters. Yeah. So that double underscore was causing it to show up bold, which is not what I wanted. Here we have another example. We have a class X object. Define M on self and J. So this is class X has a function named M that takes itself and J parameters. Here we are creating an instance of X called foo. set foo to an instance of class X. Or here, from foo, get the m function and call it with parameters self and j, and the self is implied. That's what we get even if we don't have any parameters. And here, from foo, get the k attribute and set it to q. So we've seen some of these like later examples previously, but in sort of specific versions, not in this sort of general form. And I mentioned this earlier. Whenever you create a class, for example, if the class is called name, we write class name object, and the object is itself a class, and so every class we create inherits those properties. The exception is that if we're doing inheritance, if we're making a class that's sort of a subclass or a class that is inheriting all of the properties of another class, then we would use that class instead of object. The point is that you might be able to not type this word object and it will work, but you'll get issues with Python 2 and Python 3 compatibility, as he talked about in the book. So just do it this way. So inheritance, I've alluded to a few times. So this is where you want to indicate that one class will get most or all of its features from a parent class. So, for example, if you type class foo bar, this says I'm going to make a class called foo that inherits all the properties of class bar. So when you do this, Python makes any action that you do on instances of foo also work as if they were done using an instance of bar, but also additional features that you define for class foo. And this lets you have some common functionality in the bar class and then specialize it in the foo class as needed. So, so for example, we can make this this parent class, which is just a top-level new object. We're going to define this function called implicit, and it's going to print. It's just going to print this text, but what's going to tell us, it's going to give us some information about where we are in the code. So it's going to say, I'm going to print this word parent that tells me I was in this parent object, or parent class rather, and that the function's called implicit. There's some more examples in the text. And then we're going to create a second class called child, which is a class of parent. And all we're going to do in this class is just run this pass command, which basically says don't do anything in this block. We've already done everything we wanted to do. We're done. What this is going to do, though, is it's going to create this second class called child, which inherits all of the properties of parent, which in this case is this function called implicit that's going to print these words parent implicit. So if we then create, we can do this all now in the notebook, right? There's nothing special about classes that we can't run them in the IPython notebook. So I'm going to define these classes here, instantiate them, or create two variables. So we're going to have a parent object called dad and a child object called son, and then we're going to run these functions implicit on both of them, and the output for both is this string parent implicit, because both have that function. It's just that son, because it's a child object, inherited that property from the class parent. So this is called implicit inheritance, and it's also possible to override a function in the parent class by using the same function name in the child class, or you can switch between the two versions of the function name using some Python magic that is described in Shaw exercise 44. So I won't cover that. Right now, I just wanted to also talk about composition. So this is basically where you're composing your classes using functions from other classes rather than relying on implicit inheritance to arrive at the same result. So for example, here we're going to create a class called other, which is a top-level class, and we're going to create another top-level class called child. So other is going to have this this function called implicit, which is going to print other and then the word implicit. And then class is going to, first we're going to initialize it. When we initialize it, we are going to create an instance. We're going to create this, give it this other attribute, which is an instance of this other class, and then we're within that. Then we're going to define a function that when we call the function implicit, we're going to call this attribute, which is this other class dot implicit. So within this second instance, we are making an instance of the first object type, the first class, which is going to inherit everything, and then effectively we've now just taken this one part of it. Instead of inheriting everything using this sort of very strong inheritance syntax, we are just inheriting that to this one attribute called other, and then when we call the function implicit, we're going to actually call the implicit function of that attribute, which is what we defined up here. You probably have to stare at this for a while to see what's happening, but I think what I just said is accurate. So we're going to now instantiate child as a variable called son and other as a variable called stepson, and then each of those, based on how we set them up, has a function called implicit. And so when we run this whole thing, we're going to print this phrase other implicit for each case. Now, both of these allow us to do basically the same thing, and they're both defined just like using modules more generally, or functions. They're both ways in which we can avoid reusing code. We want to avoid reusing code because it's less clean, it's less efficient. Inheritance allows us to do that by creating a mechanism for you to have implied features in base classes, which are then inherited by other classes. And composition solves this by giving you modules and the ability to call certain functions in other classes. So Shaw has these recommendations that I'll share with you here. So he says avoid multiple inheritance as much as you can, which I believe is it's not inheriting the same thing many times. I think it's maybe doing it within another another case. The other two recommendations are to if you have code that's or little bits of code that you're using in many different places around your script or your program, composition is a better way to go. Whereas if you have if you want to make multiple pieces that are all fitting under a common concept, like one of these base classes that you want to then have inherit by all your other classes, you can use inheritance for that.